Hello guys, myself Sheikh Basha. I'm from mechanical engineering. My roll number is 2295A0314. My tech talk is based on probability and statistics, and my topic is the BBIT normal distribution. Introduction. BBIT normal distribution. M- Remember that the normal distribution is very important in a probability theory, and it show up in any in many different applications. We have disused a single normal random variables provisionally. We will now talk about two or more normal random variables. We recently saw in a theory too that the sum of two independent normal random variable is also normal. However, if the two normal random variables are not independent, then their sum in is not necessarily normal. Definition 1. Two random variables x and y are said to be BVIT normal and joint normal if ax plus by divided by ax plus by has a normal distribution for all a b r. If the above deflection, if we let a is equals to b is equals to 0, then ax plus by is equals to 0. We agree that the constant 0 is a normal random variables with mean and variance 0. From the above deflection, we can immediately consume the following facts. If x and y are BVAT normal, then we let a is equals to 1, b is equals to 0. We conclude x must be normal. If x and y are BVAT normal, then by letting a is equals to 0, b is equals to 1, we conclude y must be normal. If x is x similar n mu x comma sigma square x and y similar n mu y comma sigma square y are independent, then they are joint normal. Theory. If x is similar n mu x comma sigma square x and y similar n mu y comma sigma square y are jointly normal, then x plus y similar n mu x plus mu y comma sigma square x plus sigma y square y plus 2p 2p of x y sigma x sigma y. But how can we obtain the joint normal PDF in a generally? Can we provide a similar way to generate a joint normal random variables? The basic idea is that we can't start from several independent random variables, and by considering their linear combinations, we can obtain BVAT normal random variables similar to our distribution on normal random variables. We start by introducing the standard BVAT normal distribution and then obtained the general case for the standard one. The following examples gives the idea. We call the above joint distribution for x and y the standard BVAT normal distribution with the con- corrections coefficient p. It is a distribution for two joint normal random variables when their variance are equal to 1 and their correlation coefficient is p. Two random variables x and y are said to have the standard BVAT normal distribution with where cor- correlation coefficient p if their joint PDF is given by fxy into fxy of x comma y is equals to 2 pi root 1 p square 1 1 by 2 pi root 1 p square x, exp minus 2 1 by 2 1 minus p square x square minus 2p xy plus y square, where p 2 1 minus 1 by 1. If p minus 0, then we just say x and y have the standard BVAT normal distribution. Now, if you want to join normal random variables x and y such that x similar n mu x comma say sigma square y sigma square x y similar n mu x comma sigma square y and p of xy is minus p, you can start with two individual independent n 0 comma 1 randomly where random variables of z1 and z2 are defined. X is equals to sigma x z1 plus mu x, y is equals to sigma y p z1 plus root 1 minus p square z square b square z2 plus mu y. We can find the joint PDF of x and y as above. While the point PDF has a big formula, we usually do not need to use the formula itself. Instead, we usually work with properties of jointing normal random variables such as their mini variants and curves definitions are equally in the sense that if x and y are jointly normal based on one definitions, then are joined normal based on the other definition too. The proof of their equivalency can be calculated from provided problems. One u each section. In the problem, we can show that the two definitions result in the same momentum generation functions. Definition is two random variables x and y are said to have a Bewitt normal distribution with the parameters mu x mu y comma sigma square x comma sigma square y mu y sigma square x sigma square x sigma x 2 mu y sigma square y sigma y2 and pp. If their joint PDF is given by f of fxy of x comma y is equals to 1 by 2 pi sigma x sigma y whole root, so 2 pi sigma x sigma y root 1 minus p square expect minus 1 by 2 into 1 minus p square x minus mu x by sigma whole square y minus mu y by sigma y square whole square minus 2p x minus mu x y minus mu y by sigma x sigma y, where mu x mu y are uh, mu x mu y is greater than 0 and p minus 1 are all constant. If the above decision, we introduced a Bewitt normal distribution by starting from independent normal random variables z1 z2. Another would have been to define the Bewitt normal distribution using the joint PDF, the two definitions and equivalent mathematically. In a particular, we can state that the following: Theory 1. Let x and y be two Bewitt normal random variables. Their joint PDF is given by equation. Then there exist independent standard normal random variables z1 and z2 such that x is equals to sigma x z1 plus mu x, y is equals to sigma y p z1 plus root 1 minus p square z2 plus mu y. Proof. To prove the theory definitions, now find the joint PDF of z1 z2 using the methods of thermo transformations similar to that we did above. You will find out the z1 and z2 are independent and standard normal, and by definition staff the equation of theory 2.3. The reason we started our decision on Bewitt normal random variables for z1 z2 is three found. First, it is more conventions and then the joint PDF formula. Second, sometimes the constructions Constitutions using Z1 and Z2 can be used by solve problems regarding various normal distributions. Third, the method gives us a way to generate a sample for the behavior normal distribution using a computer programs. Since most components package have an bullet in command for independent normal random variables generations. We can similarly use the common command to generate a behavior normal variables using equation. Theory 2. Suppose x and y are joint normal random variables with the parameters mu x sigma square y comma mu x mu y sigma square y comma and p. Then give x is equal to x y is normal distribution with e into y. X is equals to x small x is equals to mu y plus p sigma y x minus u y u x minus mu x by sigma x var into y by x is equals to x is equals to 1 minus p square into sigma square y. Remember that if two random variables x and y are independent, then they are uncorrelated. It is COV x comma y is equals to 0. However, the converse is not true in general. In the case of jointly normal random variables, the converse is true. Those from a jointly normal random variables being independent and being uncorrelated are equivalent. Theory 3. If x and y are behavior normal and uncorrelated, then they are independent. Proof since x and y are uncorrelated, we have p x comma y is equals to 0 by theory 5.4 gives x is equal to x comma y is normal distributed with e e into y x is equal to small x is equals to mu y plus p sigma y x minus mu x by sigma x is equals to mu y var into y by x is equal to small x is equals to 1 minus p square into sigma square by y is equals to sigma square by y. Those py divided by x into y by x is equals to py into y for all x y are those x and y are independent, then they are those x and y are independent. Another way to prove the theory is to let p is equals to 0 and absorb the fxy x comma y is equals to fx x fy y. Thank you.